All right. Okay. So we're gonna talk about Node today. Um, just we're gonna kind of like introduce it, and you know, um, I think you may have already downloaded Node before, but we're still gonna go through the installation process. It's pretty simple. We'll just quickly show you. Could you go to the next slide, Sophia? Yeah. So um, with Linux, you just essentially run this command, or with Mac, you run the brew command. I'm just going to copy paste all the commands um, into the Zoom chat. Yep. Okay. So you essentially just use any of those commands depending on what operating system you're using. Yeah, and then you can just run the download like while we're presenting. We're not going to really be doing anything in Node until the very end of the presentation. Okay. So first of all, we should talk a little bit about what is Node.js. So it's an open source cross-platform runtime environment, and it's used for executing JavaScript code outside of the browser. So we've used JavaScript before all throughout last semester, but that was all during like when we're making a website, that was all through the browser. But Node.js, it allows us to easily develop scalable and fast data intensive applications, but you probably won't want to use Node.js for like calculation heavy or CPU intensive applications because Node runs on a single thread, and like while it's making calculations, you'll end up like the, there'll be a lot of like wait time if there's a lot of calculations. But we'll explain more about what the single thread is in the following slides. Also, because it utilizes an event-driven non-blocking I/O, um, it's really great for the data-intensive real-time applications, and I'll also show what that means in the following slides as well. But non-blocking basically just means like asynchronous. And again, Node is not a framework, but it's a runtime environment for executing JavaScript. A lot of people mistake it for like a framework or programming language, or a lot of like beginners, like people who are just learning Node um, might mistake it, but it isn't. Okay, so let's talk a little bit about how it works now. Sophia, could you go to the next slide? Oh, I think Sophia, I think you have something open because like blocking part of the slide, the participants
I think it's
on
the
like the right.
cameras of the people. Yeah.
Yeah.
There
Okay.
you go.
Yeah. Okay. So uh, first of all, like every browser has a JavaScript engine in order to convert the JavaScript code into machine code. This is something that they do so that the computer can understand what your JavaScript code means. For example, Chrome uses the V8 engine, and other browsers use slightly different engines. But this variety of engines can cause like JavaScript to behave slightly differently. This isn't really a big problem anymore, but it does. Like different browsers do use different JavaScript engines. But Node, it's actually a C++ program, and it has an embedded JavaScript engine. So it doesn't mean you're going to be writing your code in C++. It just means Node itself, the program is built in C++. And it's a runtime environment for executing JavaScript. So in fact, Node actually uses the same JavaScript engine as Chrome. It actually uses the V8 engine. But again, they have two different runtime environments. So that's like the difference between them. And Node is also outside the browser. So there is no like document object or like window object, but you'll see that um, in the demo that there's instead like a global object, which replaces the window. And there are also a lot of new capabilities, like the ability to do work with things like the file system or listen to requests on a port, which can't really do with like vanilla JS. Okay, yeah. So we'll be talking more about asynchronous in another meeting. I think we have a full meeting dedicated to it in the future. However, it is important for us to understand what asynchronous means. So asynchronous is simply means it's not simultaneous. So in the case of programming, if you have a series of tasks, 1, 2, 3, and 4, which takes like 27, 10, and 8 seconds respectively, like in this example, doing the tasks synchronously would mean you'd do them one by one after each other, and the total time would take the sum of the times for each task. However, doing tasks asynchronously can lead to a significant decrease in the time needed to finish all the tasks. So you can see in asynchronously, it just takes, if all tasks essentially like start at the same time, you have all the tasks would finish in the time it takes the longest task to finish, which in this case, task 1 is 20 seconds. So this is kind of like the limiting um, task in asynchronous. Okay, and then additionally, Node uses something called like a single threaded event loop, but you might not know what this means. So in this picture, you can see that there's like a traditional way, which is like a new thread is going to be created for each request, or the program will wait until there's an available thread. So in this case, you see like there's 4 threads open and there's 5 requests. So each thread handles 1 request, and this 5th request has to wait for the next available thread. And the only way you could like improve this is either, you wait for a new thread to open, or you have to have more hardware, or like adding more threads, which would require more hardware. However, in Node uses a single thread in order to complete all of the requests. And this is it works in, well, essentially you can imagine it as if we build an app with a large number of concurrent clients, eventually all of the threads will be busy and the clients would need to wait a long time either for threads to be available or like new hardware to be added. So you're probably asking, so how does Node handle all of the requests with just a single thread? Well, when a request comes in, the thread is used to handle the request. However, instead of waiting, it just moves on to the next request. So instead of waiting for um, res the resulting data from the request, it moves on to the next request. And when once data is prepared, it puts the data into an event queue, and then Node is simultaneously it's monitoring the event queue in the background. So whenever there's data ready, it will process it and send it back. So because a lot of these, uh, and this is actually why Node is highly scalable for like data intensive applications, because if most of your requests are going to be like just querying through a database, you can essentially just start the request, and you don't have to wait for the database to get back to you. You can move on to the next request, and it'll come back to it once the data is ready and in the event queue. So essentially, it starts all of the requests. Uh, it starts all of the requests right away. So it greatly speeds up the time, as we saw back on the asynchronous slide.
Yeah, so as Keshav was mentioning, and the way that Node works is it's very event driven. So that means it waits for events to occur. It then processes these events and then has a callback function to do something as a result of those events happening. So because Node is single-threaded, if you remember the traditional way to process requests by the server, each request had its own thread created. But in Node.js, each request, as Keisha said, is immediately just sort of put into the queue, which allows the environment to work very asynchronously and makes it more efficient. So if you look on the diagram, you have things called event emitters, which are things that trigger events. And events can be a wide variety of things, like such as moving your mouse on the screen or clicking a button. And then these events are put into the event loop, where they are eventually processed and then sent to the event handlers, which are basically the callback functions that determine what the program should do with the event loop. So that's just the basic overview of how that works. So next thing I'm going to talk about is a concept that isn't unique to Node.js or even JavaScript alone. If you've coded in Python or virtually any other coding languages, you've probably encountered modules. And what modules are, it's basically sets of functions or variables or just data in general that you may not have direct access to in your current file, but you want to have access to. And modules are helpful in the sense that, if you want to have a certain file dedicated to functions of a certain kind that you don't want to, recode in a different file, it allows you to have more efficient code and more organized code. And also, if you want to use the square root function, for example, you probably should use a module for that rather than just re-implementing that all by yourself. So as I mentioned, you can create your own modules by exporting, by writing some functions or declaring some variables and then using the export keyword. I'm not 100% sure of the syntax, but one way that you can export a function that you create would be the module.exports. The name of the function. So that's just one way to do it. Or you can choose to import an existing module. That would be, think of like math module. That's one example, and we'll look at some other examples pretty soon. If you want to actually import the module into one of your files, you would use the require function into which you pass the name of the module. If you want to add a pre-existing module, as in one that's built in, you can just put the name, but if you want to use your own, make sure you have the file path mentioned inside of the require function. So basically something like the example below, or something similar to just indicate where the file is located in the directory. So if you look on the right, we have two examples of HTTP of two modules being imported into the file or the program. First, we have the HTTP module. So the name in brackets is the name in the quotes is the official name module, which is what you want to pass into the require function, which imports the module. But the variable name could really be anything. So as for these two, we have HTTP module, which is used to create servers. And we also have the event handling module, which is called events. So with that said, we can go to the demo. And we're actually going to start talking about something that we kind of touched upon already in the presentation. It's this idea of Node working in the back end rather than on a browser in the window. And it's essentially the idea of, if you think about front end, you have the three languages, HTML, CSS, and JavaScript. So JavaScript works typically in the browser or in the window. So if you have a function, for example, like console.log, this would be what we would call a global function. That means it's accessible in any file, anywhere. However, the way that JavaScript works, you can also write this way, because this is a global object that is also accessible in the window. However, if you are trying to write a NodeJS object, you're not going to use a window object, rather you want to use a global object. And that is because, as I said, NodeJS doesn't necessarily work on the front end side of the code. Rather it works in the, so it wouldn't need to use the normal window. So instead we would use global. So this isn't necessary to say. Oh, I don't think you need to say this, or maybe you do, but I don't think you need the parentheses there. But yeah, so if you're trying to code in Node.js, global is what would be the prefix. Window is in regular JavaScript, but the shorthand method is, it's okay to just say console.log. But at the same time, there's also the concept of, we started talking about the concept of global objects. So console.log is global. Anything, you can think of it as being already built into JavaScript. So what about variables that you yourself create? So for example, let's make a variable hello that is a string. Would that be global, or would it be, private? And you can, and if you were to try to make it global, if you were to try to print hello, make it global, you can go into the console and you would see that it is undefined. And that is because anything that is declared inside of a module that you create essentially is going to be private or basically just confined to that module. So even if you try to make it global, it's not going to work. And the reason for this is if you have too many global variables that can get in the way of each other, if you have the same name function in two different files that I guess require the same name, but have different functionalities, it can become a problem if one overwrites the other. So that is the main idea behind global objects and messages.
So I just want to add a note on.
Okay.
Yeah. I know a lot of you may have taken like Java or APCS, just like basically the scope is going to work a lot like Java, where, if you just declare a variable, it's going to be within the file, or if you declare one within a function, it's just within the function, and, so on and so forth. But you can still declare in Java, you can declare public variables, which are, which you can use across like different files, right? But it's kind of the same way, except you can declare like global variables across the different files. Yeah, so it's the scope works a lot like Java.
Yeah, I'll add on to something about the scope. Yeah, everyone may have seen like both people using var and let, and you might be wondering what the difference is. So what var actually does is it puts the variable on the context outside of the brackets. So can I quickly share my screen? Let me share my terminal here. So if you do var a equal, or like test var is equal to hello, and then var test var 2, or let test var 2 equals hello, These two are functionally the same in this context. Oh, I'm sharing my messenger as well. That's funny. All right. Anyways, so the place where it actually makes a difference is, can you guys see my screen? Let me see the chat. Yeah, so the place where it actually makes a difference is when you're using it inside brackets. So say I have like a if, let's say var, you know what, let's just do let if true. I just want to go into an if statement and I have a bracket to open it up. And then inside here, I want to create a variable. If I do let test var 3 equals some value, and then close off this, then when I'm outside of the brackets, I can't access test var 3 because it's not defined, right? It's confined within these two brackets. But if you use var, let me, if true, and then if I use var here instead, JavaScript is a bit stupid, so you can actually access it now. So if you want to confine your variables within brackets like you would expect in every other language, you should use let. Okay, that's all I wanted to say.
Yeah, that's an interesting point. But I guess just to wrap up conversation about global and scope, if you do want to include a variable or a function from a different file, this is where importing and exporting modules comes in. So for example, I have a certain function or a module that has a say hello inside of it. And this is just the syntax I was talking about if you want to export something. So if you wanted to export that or to import that into the main, you can use the require. So let's just call it hello module 1 and use the require function. Oh. And since it's located in the same folder, we'll just use the file path, and it's in module 1. We can just add JS. We can now say hello module 1, say hello. Make sure to save it, and you can run it, and you'll see that it now prints out something that prints out a function that wasn't located originally inside this actual file. So this is just the global method, the global objects conversation part of it. Now let's actually try to create a simple HTTP server. So the way you would do this, if you remember, there was a certain module, the HTTP module. So let's just quickly import that with the require function. Name is HTTP. And what this does is we'll just have a constant HTTP that is basically set to the module HTTP. So we've imported the module, but we don't actually have a server yet. So we actually have to use the create server function from the HTTP module. And we can set that to a server object, so we can just save it and reference it for later. Now, creating a server is one thing, but you want to be able to do something or actually, have the server be located at some place. So you can do server.listen, and here is where you would put a port number. So each computer is able to house a large number of servers, but the way that you would differentiate between each server is via things such as things that are called port numbers. So a common port number would be such as port 3000. And this basically just says, go listen to the server that is located at port 3000. That way we can actually, access the server when we go to the browser. And we want to be able to do something, when we actually go to the server. The main point of the server is to receive requests and to give a response and to process them. So in the create server, we can actually pass a function, which is going to do just that, is going to process the requests and the responses. So this function requires two parameters. You can put the request and the response. And inside of it, you can do a wide variety of things, but we'll just keep it very simple. Let's just have, in here, you can put a lot of cases for requests. So let's say a request for a URL. Let's say that the URL is just / which just means that you're going to give it as like the default page of your server. And now I need to give a response. So the request was the URL, and we now need to actually give a response from the server. And you can do this by saying, so you can do this by saying response.write. This is just one of the few things you could do. Don't feel limited to just this. You can actually look in the directory and and check out all the other methods that are available. But let's write something super basic. If you go to the server, you can just say hello world, and then make sure you also end the response after. So this is just a very, very simple server. And also at the very end, you could just say that just a little to make sure that it works. Now, if you go down here, oh, go ahead.
By the way, I just want to quickly say, by the way, it's listening. I don't know if it was like clearly explained enough, but when it's listening on port 3000, this is like, it's listening on your computer. Well, I guess that's kind of obvious. And then when you go to localhost port 3000, it'll, you'll see like it write hello world or something.
Yeah.
So that's what would happen here.
Yes. Yeah, Keshav is right.
It should also be noted that when you use like a local host server, it's not publicly accessible. So if people inside your network or like inside your house can probably access it, but people from outside your home won't be able to, pretty much, unless you set it up like properly, which is quite a hassle on its own.
Yeah. Basically, this isn't something that you actually want to use for a real backend server. It's really simple. So you'd probably want to use more complex things, but we'll go more in depth on that later. So now, as you can see, it's going to say listening on port 3000. So if you go to your browser and you enter in localhost :3000, you'll be able to see a message, hello world, pop up. And if you want to actually,
sorry, can you change the screen share for the browser?
Oh, yeah, sure.
It might be only on VS Code.
All right, so if you were to go to localhost 3000, you'll see that up here we have hello world written out. Okay, so let's go back to VS Code really quickly. So you're not just limited to one if request thing. You can also go to, let's say, a different side of it. Let's do /by. We can do the same thing, write a different message, and the response. And now if you run if you want to close the server, you do Control-C, and then you can do it again. Let's show this. If we go back here, it says hello world, but if we go /by, you'll see that up here, the message changes to by. So this is.
I think you're sharing the wrong screen.
Oh,
you're showing VS Code.
Sorry about that. There it is. Is that the right side? No.
Looks about right, yeah.
Yeah.
Oh, can you see it now?
Yeah.
Okay, yeah. So if you were to go to the old page, it's just hello world, but if you do /by, you get a new page. So in the end, though, this HTTP server is really only good for really simple tasks. As you can see, like as if we were to add more and more sort of URL links or other methods, then it would get really crowded and overly complicated for an HTTP server. So HTTP servers are really only good for simple tasks such as sending requests to other servers. If you want to make it more, I guess, complicated, or not to say complicated, but if you want to have a more elaborate server that are efficient than the HTTP server, you can use certain frameworks such as Express, which will help organize the code a lot better and just makes it more efficient overall. But that is just a little demo on HTTP servers in Node.
Cool, epic, thank you. All right, let's put the sign-in link. The sign-in, there it is, copy. And the code today is, nobody would guess it, it's Node. Wow. Thanks for coming, everyone. Make sure you sign in with the link.